I'd like to introduce James Carton. James is a professor in the School of Mechanical and Manufacturing Engineering at DCU. He's a Science Foundation funded investigator and works in the area of sustainable energy and hydrogen in the School of Mechanical and Manufacturing at Dublin City University. Dr. Carton is a Hydrogen Task Force expert to the UN ECE, Chair of Hydrogen Ireland Association and Hydrogen Mobility Ireland Academic Advisor, as well as World Class Energy Council FEL alumni. Dr. Carton's research focus is hydrogen techno-economic modeling, hydrogen for mobility, Pro-to-X, renewable energy storage, and hydrogen policy. This evening, Dr. James Carton is going to present on the future of transportation, hydrogen, and electric. I'll pass over to James now. Thank you.
Thank you, Dermot, for the introduction. Before I kind of start my presentation, there was a lot of my introduction there was about hydrogen, but I'm going to talk about this evening, I'm going to talk about the future of transport, and I'm going to cover hydrogen certainly, but I'm also obviously going to cover electric. And the future is electric, and you'll kind of hopefully go through this kind of this story with me. And I would invite you please to put up questions as I go along, and I'm happy to cover any areas of transport, hydrogen or electric. And I'll go through this. And my presentation is only going to be about 30 minutes. I'm going to leave loads of times for discussion and chat afterwards. So really, when you talk about transport, you need to think about the environment, climate change, and human health. And that's kind of the take I take on as a sustainable engineer in DCU and as my role in understanding energy systems, including the transport sector. So energy use in Ireland is quite stark, really, when you kind of look at it. This is a Sankey diagram by SEAI. Our energy inputs here on the left, and we look at oil, which mainly goes into transport. And transport of the energy sector covers about 37% of CO2 emissions. And that's a lot. That's a big sector of our economy that has to decarbonize, a big sector of our daily lives that we have to develop and understand and to try to get reductions in those carbon emissions. And if you look at this diagram here from the EPA on their recent study and kind of the projections towards 2050 and kind of, looking at decarbonization to 2050 across transport, built environment and electricity. And, people have a kind of an idea around electricity. Yeah, wind turbines and solar panels and interconnection to the UK and Europe. We could probably, and batteries, and we can kind of more or less understand a decarbonization of electricity. Built environment is really difficult to understand because you have to think about your home and the expense and costs around that. But transport is also, as from an individual even or as an engineer, in any level of society, it's also kind of a little bit, will I just change my car to something that's a little bit better? And I want to tease out that expectation here today a little bit, and actually kind of look at what we could do, should do, and see if you agree with me and maybe have a bit of a discussion around it. So the way I look at it is the only option for transport in our society, if we are to be a society in a number of years' time that exists and combats climate change and has a healthy relationship with our transport systems, it has to be zero emission. There's no excuse for anything less. It won't be diesel, it won't be petrol, it won't be fossil fuel, and most likely it won't be biofuel or any median fuel either, because they don't allow tailpipe zero emissions. And this is what I'm wanting to really get through: is tailpipe zero emissions important, and then life cycle low emissions, or as low to zero as we can is important. So we're aiming for an A0, it's called, in relation to a CO2 band in a vehicle, we'll say. And if you look at an A0 band, the only options you have are hydrogen and electric. And interestingly, both these vehicles that you see in front of you here, the one on the bottom is the Toyota Mirai that I drove just before lockdown, actually, in the Netherlands, filling it up with hydrogen here as I was on a 150-kilometer drive around with a colleague in it. And the car up the top, the electric vehicle, is my own vehicle. It's a Hyundai Ioniq, fully electric. I've had that 2 years. So again, any questions you have about electric vehicles and how they work and why I converted and why I would never go back to anything less than an electric vehicle, happy to answer that. But the key point I'm trying to make here is zero emissions. Both these vehicles are zero emissions, and both these vehicles are electric. The only difference between the top vehicle and the bottom vehicle is that there's a smaller battery in the bottom vehicle. It's got a fuel cell, and it's got a tank of hydrogen. The motors, the regenerative braking, the feel, the comfort, the zero noise is all the same. The only difference really between the top and bottom as well is the range on the bottom is currently at the scale of around 600 to 700 kilometers, and the electric on the top will get to possibly around 400 kilometers average on electric vehicle over the next 2 or 3 years, and that's probably where it might sit actually. And we'll talk about that in a minute, why that might be the case. And then the only other difference between the two vehicles is my car is plugged in there and plugged into my house. And I charge that at nighttime actually. Whereas with a hydrogen vehicle, you're not going to have a fueling station in your backyard. Most depots even that will have fleets of vehicles probably won't even have a hydrogen fueling station in their backyard. It'll probably be a national fueling network. So let's dive in here, and we're actually going to look at electric vehicles first. And so from a market point of view, Ireland's actually not bad. Usually we're at the bottom 10 in the world or something, but actually in relation to market share in 2019, Ireland actually was quite good in relation to the amount of electric vehicles sold within our market. We're nowhere near the likes of Norway, but everybody else that we're, every other Western European country is fairly similar. However, we have a very small population, fleet of about 2 million passenger vehicles, we'll say. So, from a global percentage of amount of vehicles, we're actually very low because, other countries are bigger and they have a lot more vehicles. But from a market share, we're quite good. So to date, about 9.5 million electric vehicles are on the roads, okay? And 2.3 million of them were sold in 2020. And actually more than half of that number, 1.2 million, I think, was sold in China alone in 2020. So these are the numbers that you're working with. Now let's actually put that in perspective. The global fleet of vehicles is about 2.2 billion. So electric vehicles are very small and are pretty much doing zero impact today, and probably won't do much impact in global emission terms from a vehicle point of view. So let's look at this again. So interestingly, 63,000 EV buses were sold in 2020. 95%, but 61,000 or in that range, was sold in China. That represents about 14% of their bus fleet. That's interesting, considering the rest of the world had about 2,000 electric buses sold. And then this is an interesting graph that I would like. I agree with the trend. I'd be changing the year on this, but certainly, when you go to buy a vehicle, if that's what you want to do in 2021, with everything going on, you're kind of presented to, here's a diesel, it's way better, I swear. Here's a petrol, here's a hybrid, and oh, by the way, there's an electric as well. And, a lot of people are kind of going, hybrid is maybe the transition vehicle that we'd like to go with. But hybrid has a limited lifespan. Certainly the not plug-in version has a very limited lifespan. in the overall theme of evolution of our transport system. And the plug-in hybrid is quite good, but again, it's just not good enough, you know, in relation to actually what it does in relation to reduce emissions, increase efficiency, and tailpipe emissions, you know, need to be are still there for much of your kilometers you travel. So, and interesting with this Bloomberg graph, the gray actually is kind of a mix of internal combustion engine and hydrogen electric vehicle. And again, the breakout of that is, it gets a little bit, you know, fuzzy as we go into the future. But I think the interesting thing here is that the share of electric vehicles will increase. Battery electric vehicles certainly will increase, up to maybe a large version of global fleet in the 2030s and 40s, which would be good, because that would mean that maybe the OECD countries have bigger fleets of electric vehicles, and then developing countries will have you know, gaining traction on deploying of electric vehicles. So let's look in Ireland, and this is taken from CME website, or stats beep.ie. And you know, 2018 really set the year that I bought my Hyundai Ioniq. And in that year, electric vehicles were affecting 1% of market share. 19 then went up to almost 3%. Last year, it was just over 4.5%. And actually interesting, last year, 2020, COVID year, diesel and petrol car sales are down by 25%. Now, there's issues there, obviously, with COVID. People realized that they didn't probably need their car, working from home. You know, car sitting idle in the driveway. Maybe there's an idea of that. Well, actually, do we need two cars at all for every family? So that's a very interesting, just an anomaly that happened last year. I wonder will it happen this year? But to date in 2021, EV sales are already double the year-to-date figures of 2020. So are we on a market share of 8% this year? I'm not sure, but we'll see. But why is transport emissions rising in Ireland? So here, and actually all across the EU, it's rising. The transport emissions are. So I thought we were moving to EV. We have some hybrids on the fleet, and there's a small decline in petrol and diesel across the European Union. But why is it increasing? Well, the fact of the matter is we're buying the wrong cars. SUVs are one of the biggest problems with our transport system, passenger vehicles certainly, that we see. SUVs have completely eliminated all the gains that we've had with emissions reduction systems on our car fleet, and it's also eliminated all the conversion of diesel and petrol to EV, and now our emissions are going up again, and that is all to do with OEM manufacturing and allowing their cars to be bigger to house the batteries that they have if they're hybrids, to house the bigger batteries to get longer range if they're which then makes them into an SUV range or model, and it also applies to behavior and our behavior as a customer, our society's behavior, and education around vehicles and emissions. So let's look at hydrogen. Now, the interesting thing with EVs that I looked at was EVs, electric vehicles, battery electric vehicles, mainly focus on passenger car market. And the transport system is way bigger and way wider, and we're more diverse than just passenger cars. So hydrogen always tends to widen that net, and it focuses in on buses, trucks, and passenger cars and logistics vehicles. So interestingly, globally, there's less than 600 hydrogen fueling stations across the world in 2020. And again, you could name, or I can name the countries, you know, California, Germany, South Korea, China, Japan, and maybe somewhere next will be UK and France and other countries, Austria, have the fueling stations. And then there's a splatter of fueling stations across many other OECD countries. But actually, if you look at kind of the numbers of vehicles on the road, well, they're very, very small. You know, we thought that 9.5 million EVs, battery electric vehicles, was small. Fuel cells are tiny. So you have 15,000 vehicles, again, mainly sold in the countries I mentioned, about 2,000 buses, mainly in China, and 1,500 trucks, mainly around Europe and China. And 30,000 forklifts, actually mainly in the US, believe it or not. So it's kind of interesting to see that the numbers are really small. But again, a lot to do with these numbers, and certainly with the EVs as well, is that, you know, before 2017, there was effectively, you know, Tesla was the only electric vehicle manufacturer in the world, you know, and then they got famous, and a lot of OEMs came on the scene very fast. And we saw actually how fast Volkswagen came into the market from being the boldest kid in this class to the best in class with EVs. So we can see how OEMs can change overnight, quite literally, retool their factories and develop. And we're seeing that already in the OEM market, in the hydrogen vehicles, where you see that Toyota are up in their ante of producing 30,000 vehicles per annum. And 30,000 is a lovely number if whoever's in manufacturing, because that's your mass production scale level of vehicle. That kind of things make sense. Prices go down at that point. And we can we can have the discussion around costs of hydrogen later if that's of interest. So hydrogen going on to 2030, well, there's lots of stuff being planned. So, you know, if you kind of look at everything, between all the plans coming together across different countries and regions, US, Europe, China, and Japan, there's lots of vehicles aiming to come on. A lot of them are passenger vehicles, but there's a lot of buses, trucks, and trains all set to come onto the market, or not come onto the market, grow in the market, we'll say, take up market share in the market. And, you know, equivalent to effectively, if you kind of fueled all these vehicles that have been pledged by these countries up to 2030, you'd effectively equate to, you know, half of Ireland's entire carbon emissions reduction across the world, assuming your hydrogen's green. And for the sake of conversation, I will be assuming all the hydrogen is green in my conversations from here forth. So let's look at the hydrogen electric vehicle market in Ireland. Well, there was none in 2018, there was none in 2019, there was none in 2020, and we don't expect any in 2021. So what we do expect, though, in the hydrogen is that, you know, cars isn't actually the focus. And this is the whole idea that I'd like to have a debate maybe today around, is actually decarbonization is the idea. And if you want to decarbonize, should we concentrate on Ireland's 2 million car fleet, or should we concentrate on the 100,000 trucks that create 25% of the 37% emissions in the transport industry? So I think, you know, from a decarbonization point of view, we need to decarbonize the heavy goods vehicles and reduce the amount of vehicles in our fleet. So where we see hydrogen vehicles certainly is that buses, trucks, and fleets of cars, not necessarily individuals driving cars, but fleets of cars are certainly a road where hydrogen should go. So again, for the policy people in the room, what should we focus on? Well, it's kind of, you know, when you look at the array of transport in our society, a key thing with this is the normal thing of decarbonization. That's the only thing we need to think about. And the things we should focus on are the things that don't have carbon connected to them. It's the active travel, it's the electric scooters, it's the electric bikes, and it's the you know, active mobility or active travel. Then we need to focus on, and I'm really glad that I think the COVID restrictions are allowing more people on public transport. But public transport, you know, putting people on public transport, extending public transport, making more trains available, extending rail lines instead of closing them down, extending bus routes, is something we need to do as a society, rather than decarbonizing something that's really difficult. So, and then make that public transport, make that the company, the semi-state or the state-owned companies be leaders in deploying out zero emission vehicles, because there is no compromise with zero emission. If your vehicles are going anywhere near people's lungs, they should be zero tailpipe emission. And then cars and airplanes, well, we'll talk about that in a minute. So this was kind of why we brought in the first hydrogen bus into Ireland just before Christmas. We kind of said, actually, we need to learn about this. We need to learn how we can decarbonize our transport system. Let's focus on HDVs, heavy duty vehicles, like buses, like trucks, and let's learn from it. Let's see, how does it work? Is it the same? Do passengers even recognize it? Do they have issues with it? Is there a safety concern? You know, who do you have to involve? How do we set up fueling? How do we have to refuel the vehicle? What's our kind of travel like, logistics, all those type of things. So all these people on this slide, these are all the people we had to engage with this to get this one bus on the road for about 8 weeks. And it was great, actually, engaging with these companies to actually pull this project together, to get a bus, to learn from it. And at the moment, I'm in the middle of publishing a report on this for public dissemination, effectively, on the trial, given all the data around the trial and the emission savings and the hydrogen used, etc., on the trial. So again, if you have any questions on that, happy to discuss. And actually, this trial, as I mentioned during the time, this is the first of many that's happening. So 2 weeks after we started, there was the first bus came to Northern Ireland. They're now rolling out a number of buses, and they've got orders for 20 hydrogen buses, I believe, for the fleet. And then at the same time, there's 3 more double-decker buses coming into Dublin over the next couple of weeks, I believe. And they'll be trialed over the summer, and then passengers will be coming on them over the next couple of months. And again, it's as my colleagues in Dublin Bus Air talked to me, it's not a trial. When you have 3 double-decker buses going around Dublin City, it's a deployment. It's a deployment of this new transport. So again, when I look at all the hype around transport and decarbonisation, the hype around electric vehicles is only for passenger vehicles, and it should be about heavy-duty vehicles, because they're the bigger emissions, and there's less of them. So that's where we should focus our efforts, and really, if you know, allow the opportunity of, you know, this is a map here from Hydrogen Mobility Ireland. 30 hydrogen fueling stations across the entire island can accommodate every or any vehicle you want to run on hydrogen. Comparing that to, we just downloaded the network of charging stations across Ireland, and there's, I think, over, forgive me, from somewhere between 2,000 and 3,000 individual charge points on the island at the moment. And everybody's still giving out about we need more infrastructure. And what we see, which when you go to build infrastructure for, you know, fast charging, and certainly for cars, you know, fast charging in my car takes 20 minutes. I'm happy with that. I've driven all around the entire country in an EV, and it's great. But I still end up on a traffic jam on the M50. Even now, as we come out of COVID, traffic has gone worse. But if you're to transition your entire 1,000 buses or 1,000 trucks of your fleet as your fleet owner into electric, so the vehicles are available, like the hydrogen vehicles, they're available. That's not the issue. The fuels are available. But the problem is actually you come into grid issues. You come into actually the power you require when you require it, you might be not able to get it. So what we'd see, certainly, or I'd see as a looking at transport, is that as you're developing your zero emissions transport system, certainly the HDV section, you will see a very integrated mix of electric first for all those vehicles in the mid-size range to the higher size range to be electric, and battery electric. And then as the the complexity of that route and requirement of that vehicle increases, then that would switch on to hydrogen. And that's quite normal. That's, you know, that's, if you think about it, that actually makes sense. So if you're thinking about 24-hour vehicle runs with no brakes, you have long haul haulage, whether it's on the island, international to the UK or international to Europe, it makes sense that these vehicles should run 24/7. And then all you do is swap out the driver. And when you come up to fueling it, it should take, you know, a few minutes, not a few hours. But if you're just running around a small area and you park up night, go battery electric. So this is kind of interesting things that it's anomalies that we know 100% around the transport system, but we don't seem to implement it in our policies or in our plans. The thing that we've done here with in DCU actually, and we're in the middle of it, so I'm going to ask you at the end. There's a survey if you're interested in engaging with it. Please do. But what we've done is we've engaged with a lot of the truck industry in Ireland, and we've asked them, you know, kind of a number of questions around zero emissions vehicles, or as you transition to zero emissions, what is your highlights would say. And it's very funny. The truck industry is very pragmatic. They don't really care is the short answer, as long as it works with their system, and their business can continue and even flourish because of their investment in the vehicle. Now, there's obviously a few kind of caveats there. The vehicle cannot be too expensive and the fuel cannot be too expensive. But certainly what we see is that, you know, the things like support, reliability, sustainability, backup supports, and the availability of the fuel, for example, is already really more important than actually even the cost of the truck. So these are kind of interesting anomalies, which is very different than an individual person buying a car. You know, if you want to buy a passenger car, you usually kind of look at the where you put your coffee cup, and you know, is there heated seats? Whereas the heavy duty vehicle operation is very, very different and very, you know, it doesn't really matter if there is battery electric vehicles available. That's what they should go for. But if they are not suiting their range or their logistic requirements, it obviously doesn't make sense, and that they would all automatically just flip to hydrogen once they're available, when they're available. The other thing we're seeing is they still see there's barriers that people perceive for hydrogen, the cost of purchase of the vehicle, and then vehicle performance reliability question marks. We're seeing that already, or we see it in the UK, certainly in Northern Ireland, the UK, and rollouts of bus projects across Europe and truck projects across Europe and even New Zealand. And you kind of, you know, there's only at the moment in 2020, 2021, there's only a few OEMs that are making these vehicles. But as I read on an article this morning, this decade is going to be the boom for zero emissions trucking, and that's across electric and hydrogen, which is really good. Again, don't be biased, just buy the right one for your business. And the other things, like all good truck companies, you know, a purchase grant. And again, the question here is that you want to bring down a vehicle to be in the same par of equivalent diesel vehicle. You want the motor tax to be equivalent, and you want obviously fuel available. And if it's too high, it won't be suitable for the business. So you need support there. So they're all interesting insights that we saw from the survey. And again, we'll be publishing this and it'll be freely available for people to interact with over the summer. So what we see, or where are we going with Ireland, and what is kind of the steps of what's happening and what should we do? Well, there's a few things happening around Europe, and we should kind of maybe recognize that maybe we should engage with some of these things, and that's banning decline of fossil fuels. This actually used to be decline of diesel, but now I've just changed it to decline of fossil fuels. So the question isn't even, you know, will my next truck purchase will it be a diesel or will it be a zero emission? The question that trucking companies are asking, and HGV companies are asking, is we are moving to low emission vehicles. What options do we have? Can we start planning it? And that's the we're still a bit late, but still it's good that we're having those conversations. And I think that's important to see where we are. We do need to plan today so that our fleet of vehicles, our dirtiest vehicles, our heaviest vehicles, our most fuel intensive vehicles are decarbonized as soon as we can. So is there opportunity not to ban, but certainly have zones of fresh air in our cities? That's an option that some cities across Europe are looking at. And then obviously the EU Clean Vehicles Directive is a really good mechanism to ensure certainly our public sector vehicles can be zero emission, and certainly our public sector should lead. No one's going to buy a low emission vehicle and help decarbonize and pull their weight as a good citizen. If you look at the public services and our public sector bodies, if they're driving around in diesel guzzling polluting vehicles. So again, the public sector must lead, and the public transport must go zero emission and must pull in more people onto this to actually make our cities and towns cleaner. So this is kind of my second last slide, and I'll finish up then, and please put in any questions you like. So I'll give you a scenario for now to 2030 plus, we'll call it. So we're here with our active travel, our trains, buses, trucks, and our car and our airplane. And the active travel, now, please, is the short answer there. There's so many good things happening around this in this COVID world. Our 5K radius has been so approved by some county councils, and it's great to see that. And I think that just it should have happened 10 years ago, but look at it's happening now. Let's progress it and push forward with it. When you go into bus and then also representing truck and train, the option there is quite simple. If you can electrify with rail, for example, Dart and Lewis, electrify whatever you can. With bus, if you can put battery electric onto it, most of, for example, bus air probably will be electric, but 70% probably will be electric. But for other routes, logistics, 24-hour night links, etc., for trains that go from Dublin to Belfast, Dublin to Cork, Dublin to Rosslare, or Dublin to Galway, intercity, you don't really have much option other than extended carriages with lots of batteries or hydrogen, and that's it. You don't have to. The interesting thing with the trains is you don't even have to buy a new train. They're all retrofitted, because trains are expensive. They're big capital devices. So again, there's options there. There's two options actually, and you should engage with them. The car. Let's go back to the car. So all our statistics and all the media is all about EVs, and I haven't talked much about them other than the fact that the numbers are really good, but to be honest with you, they're really low, insignificant almost. And the whole idea of cars is that we shouldn't replace 1 million vehicles in 2030 that could have been petrol or diesel with 1 million electric vehicles. We shouldn't have 2 million fleet in 2030. We should have probably half that. We should have 1 million fleet in 2030. That would be a lovely aim. Imagine if there was an aim to reduce the number of cars on the road. And whatever is left should go battery. And if you have fleets, so taxis and fleets of vehicles, like what you see on Post, for example, or other, I think DHL as well, they're going battery. And again, others will go hydrogen. Again, the market will play with that for certainly for cars and kind of that type of scale of vehicle. If you go aviation, well, as I said to somebody on aviation, I said, you have to think about, aviation's in a really bad place at the moment. And it's going to, it's going to be quite interesting how aviation actually comes out of the COVID downturn, how it possibly booms, but then there might be issues in relation to climate targets and climate emissions and stuff. And, you know, aviation is around 7% of our emissions, I think, in the energy system. You know, from that point of view, aviation is a small contributor, but it's very visible. You can see the airplanes flying over and their contrails out. So the public really, you need to, as a society, we need to engage with aviation and decarbonize it. Like, you know, it's really hard to decarbonize, but we should start today to decarbonize it. We're not going to replace the 30,000 or odd airplanes that are in the fleet of the world. They're probably going to be, those same airplanes that are there today are probably going to be in the sky in 20 years' time, because that's the life of an airplane. So what do? You're not going to turn it to battery. You're not going to turn it to hydrogen. And if you're thinking about turning it to biofuel, you know, forget it, because we don't have the land and we do not want a bigger biodiversity crisis than we have to produce the biofuel that we need. So the only option really is, again, reduce the fleet, but whatever is left, we have to go synthetic, and that'll come from green hydrogen and most likely biogenic carbon sources or direct air capture or something. And again, what that allows us to do is transition for the next 20 years on the fuel that we exist, so kerosene, in aviation, as the airline industry develops new airplanes that actually don't need kerosene. And again, what I ask my students in one of my modules is like, imagine you're 2070, what airplane is flying overhead? And a lot of them kind of go, it's a very difficult question, because it won't be emitting fossil fuels or emissions. So what I'd like to kind of have the discussion points around is, well, from all intents and purposes, transport needs to go zero. And whether that's reducing the numbers to zero or reducing the emissions, it doesn't actually matter, but probably a little bit of both. We need to focus on heavy duty vehicles, trains, buses, and public transport for a number of reasons. Carrot and stick, you know, the carrot and stick, it's time for the people, the industry that have HGVs, trains, buses, and public transport to engage with, to have the supports available for them. But also, if they're not complying, you know, that needs to be managed. And then behavior change in society has to happen. It's not, you know, there's no free lunch with climate change and our energy transition that we're just in. And the transition we need in our society, we're a first world country, a part of the European Union. We have to facilitate a just transition for our society. And that means we have to support, you know, rural areas that don't have public transport. We need to support, we need to put in public transport. We need to ensure that their transport is low emission or zero emission, and as much as everyone else is in the country. So on that point, I'll leave it and I'll take questions from the floor. Thank you.
Thanks very much, James, for that very interesting and thought-provoking and question-provoking presentation as well. And we have quite a few questions coming in on the Q&A. I'll work my way down through them. And first is for commercial transport vehicles, can you comment on what is relevant and where hydrogen currently stands for commercial transport vehicles?
Yeah, so look, there's for commercial transport, so HGVs we call them. So we're within Hydrogen Mobility Ireland. There's a task force within that which represents a good many fleet owners. So I maybe suggest first of all is engaging with Hydrogen Mobility Ireland. That'd be kind of, because there's a trucking group there that I think are talking about things like this. But I think from trucking point of view, like CNG is an option. It's compressed natural gas, but if it's not biogenic compressed natural gas, probably don't bother with it. But CNG is kind of like the hybrid vehicle. It has a very short lifespan before it's going to be overcome by fully electric anyway. So if I was, telling you today, I'll tell you, you'll have three options for low carbon commercial vehicles, we'll say, sorry, in the higher end of transport. I'll talk about vans if that's what your question is, Paddy. But in relation to HDVs, you have three options. You have CNG, which you hope is certified biomethane. You have battery electric, and you have hydrogen. Battery electric, there's very few of them. They're expensive. Hydrogen, there's a little bit more choice, but they're very expensive. Over the next probably 5 years, there will be probably somewhere between 500 and 1,000 on the roads in Ireland, hydrogen, and there could be probably a couple of hundred electric on the road as well. So again, we're at this time where get in your say, because I think certainly for commercial businesses, when they invest in a vehicle, they run a million kilometers on these vehicles, and then they sell them on. So you're going to have them for a couple of years. So you don't want to really change halfway through your term. So I'd kind of, there is options. Talk to the different groups that exist. That's what I'd say, maybe.
James, another question here. Is it possible converting existing vehicles to electric and hydrogen, or is that a sensible way to go?
If only I had the time, Dermot. Currently, I'm in the process of converting a Jaguar XK8 to fully electric, believe it or not. That's my COVID lockdown project. It's taken me longer than I need about another 5 or 6 pandemics to probably complete the project. But it's so from a personal car vehicle point of view, there is organizations in Ireland that do that, and it's expensive. So the idea is do it yourself, and you have to gain the knowledge to do that. I have a number of friends and colleagues that are not, that are effectively engineers. That it's quite straightforward. You get your tax changed, you get the car checked, and you go through the hoops, and you can do that. So that's a thing it's small on the radar, but it's certainly a thing that's very big in some countries across the world. Converting to hydrogen, not yet. Like one of the things we're seeing with both electric and hydrogen, or battery and hydrogen, is that there's a skills development stage. And again, as part of DCU, as part of some projects I'm running, specifically this project called High Skills, we're trying to actually understand potential skill shortages in the energy transition. And some of those skill shortages will be updating mechanics to service a hydrogen car, updating plumbers and electricians to install an electrolyzer or install a hydrogen fueling pump, etc. So there's a kind of, we're at the very start, but things are coming, and it's quite interesting. But I'd say connect with, it is conversion of vehicles to electric is a thing. And I might write a blog post on my journey if that's of interest, maybe.
There's a related question here, James, about is there a requirement for cooling of the hydrogen for that to work, and how technically feasible is that? So just in relation to the vehicle itself, the fuel cell works at 80 degrees, so that's it's kind of the heat's taken off generally to do cabin heat. I think the question is more so on refueling, if the person can confirm that. But in relation to refueling, certainly, again, this is a problem for cars versus HDVs. Heavy duty vehicles are happy to run on 350 bar hydrogen. And, the technology is quite mature, reasonably cheap, and effective at doing that. The way car manufacturers have designed their cars is that they wanted to blow BEVs out of the water. So they said, I want to get 700 kilometers. So they put the pressure requirements on their cars to 700 bar pressure. And that needs a lot more technology, we'll say, to compress that hydrogen to those pressures. And that does need supercooling, we call it, and chillers and all sorts of different things. But that's part of the kit. It's mature technology. It's not really a bottleneck, but it is an efficiency loss, for example, if that might make sense. So the cooling's required earlier on in the stage, but it's not required in the car because of the high pressure. So it can operate at a higher temperature within the car itself. It doesn't need cooling in the car. Yeah.
No, there's no cooling required.
Yeah.
That's
No. One of the questions here was somebody who had studied this in the 90s, and there was cooling required at that stage to bring the hydrogen down to liquefied hydrogen.
Sorry, yeah, but that's at the fueling station, and that's still most within transport industry, we don't bring the hydrogen to liquefied hydrogen. That's not a thing that's seen as required in 2020, and probably won't be required past or up for the next 5-6 years. What we see in international trucks, the trucks that want to drive from Galway right to the south end of Italy, and then go back to Brussels and fill up, and then go on back to Galway again, and fill up once maybe, or even twice on the route. Those trucks that probably do 2,000 or 2,500 kilometers in the run, there is talks that they could have 750 bar pressure on them, or liquid hydrogen. But again, as an engineer that teaches thermodynamics, the lower pressures for your needs, you cover 90% of the requirements, we'll say. I think, heavy duty vehicle transport will evolve over the next decade, and all sorts of things are possible. That's why I'd maybe leave it there. But certainly today, if you went to buy a hydrogen truck or bus, it's 350 bar, and you'll fly 400 kilometers on a bus, and 700 kilometers on a truck, we'll say.
The next question here, James, is related to my own interest area of materials and metals. The question is, do hydrogen vehicles require rare metals in the same way that electric vehicles do? And what's the consideration there in terms of the life cycle and carbon footprint?
Yeah. Very good questions. And again, it's a full section of my module on my master's program. From a materials point of view, so fuel cells require platinum. That's a rare earth element, and electrolyzers need platinum. The interesting thing is, if you have a car that's 2008 and newer, it has a catalytic converter, and it also has platinum in it. And the same amount of platinum, which is around 30 grams of platinum, is in these catalytic converters. So if you kind of went out in COVID and your car has a catalytic converter that was stolen, that's why they're stealing it, because it's got 30 grams of platinum in it. But that number is the same amount of platinum that's required for a fuel cell to give you a fuel cell car. So it's kind of really interesting that there's, the stock of platinum that's in the system, let's call it, is in the system. So we don't have to really mine new stuff, even though we will anyway. But there's a good kind of balance there, we'll say. The other side is platinum is required. So it's one precious element. There's a feed of it, and it's 100% recyclable within a fuel cell. The material gets contaminated with sulfur, and it gets contaminated with carbon monoxide and all sorts of things, but it can be recycled and reused as a second generation. Even fuel cells themselves, the way you manage them at the end of life, actually, the car will have an innate value because of this platinum, because of the fuel cells. So there's a very interesting second-hand market fuel cell car, which we haven't even seen yet. So that'll happen in 10 years' time. But so from a rare earth thing, the difference between batteries, we also have batteries in fuel cell vehicles, buses and trucks, but it's lower amounts or smaller batteries. The problem with batteries with rare earth elements is there's lots of them. There's a whole mirage of different elements. And again, what ends up coming up onto the news is the one or two that are kind of in conflict zones or have cheap labor or problems with labor and mining, etc. Whereas platinum is kind of your engagement ring or your wedding ring type of, it's a stock that's have been flowing for many years. And again, as I said, it's already in the passenger car vehicle, if that makes sense.
Yeah. Thanks for that, James. Some other questions, quite a few questions coming in. Do you see that hydrogen fueling stations will produce their own hydrogen, or will they be transported to the site of the hydrogen fueling station from elsewhere?
This kind of comes back to life cycle analysis, which for my sins, I think I've gotten into over the last couple of years as I develop more into hydrogen. So the funny thing with electric vehicles is that they're only as clean as the grid, and the grid sometimes isn't very clean. Whereas hydrogen, certainly in Ireland, and again, every country is going to be different, but certainly in hydrogen, the supply of hydrogen most likely is going to be green from renewables, which effectively is zero carbon. It'll have a carbon footprint moving it from where it's produced to where it's delivered, and then used within the mobility application if that's what it's required to do. So technically, on a life cycle, hydrogen has a huge potential to be a lot less emission intensive than electric. But as we go into the future, as we go to 70% renewables in 2030 and 150% or 200% renewables by 2035 and 40, battery electric vehicles will have effectively very low emissions as well. So the idea here that hydrogen can be produced on site, of course it can be. The UK has taken that on. A company called ITM are doing that all over the place. I think companies will do that in Ireland, but the question is, it all depends on supply demand. And if there's a huge amount of hydrogen supply in the renewable wind market, why would you produce it on site if it's going to be reasonable enough just to ship it in, we'll say. So it's market. The market will be the decider there, not an academic.
So speaking of that, James, internationally, from a commercial perspective and an R&D perspective, who are the main countries or the main movers, and where does Ireland stand in terms of commercial interest?
So Ireland, we're the main mover. So the really interesting I'll take this on relation to hydrogen, we'll say. The really interesting with hydrogen is every country has their own agenda, okay? And that's usually related to their mix of energy, their energy reserves, usually fossils, and their infrastructure they have and stuff like that. So interestingly, there was really fast movers. As I said, Germany last year put in a hydrogen fueling station in their country, one a week, consistently, and is still doing it. Austria, Italy, and Switzerland are all engaging with huge amount of deployment of hydrogen trucks. Then there's loads of other countries developing the technology, the fuel cells, the electrolyzers, the trucks. The right-hand trucks, which is interesting, for New Zealand are being built in Netherlands. So I think Ireland, we're coming late to the game, but this is usually what Ireland does. We kind of come in late and we kind of go, well, what is everyone else doing? Yeah, we should do this. So I think that's where it's happened. So we're not coming in too late, but if our policy stalls another year or two, probably will be too late. But we're coming in at a good time, and everybody and their neighbour realizes that Ireland's renewable production potential has huge implications for our electricity system, our energy system. And that has huge implications on the fact that we can decarbonize a huge part of our economy by electrifying everything. Heat pumps, electric vehicles, that's a really good idea. But it also sets out the idea that we probably have a load to spare renewable energy that we need to do something with. And this is where hydrogen comes in. And I gave a talk to the United Nations there a couple of months ago. And there was all these hydrogen strategies being developed across Europe. And I put out the map of Europe, every country with blue, because they're talking about blue hydrogen. And I put Ireland as green because we're probably really best placed to produce green hydrogen on huge scales for our own use and decarbonization strategies, but also for export to Europe. And that sets us apart. The fact that we don't have fossil fuels is a good thing in this case. The fact that we don't have any or don't want to drill any for gas or oil is probably a really good thing for Ireland in our future.
We're coming to the end of the time frame, just at the hour point at 7:30. But maybe just to touch back on that question, James, you mentioned earlier in the presentation the distance that the cars travel can be 400 kilometers for electric and 750 for hydrogen, and that's a limit in terms of where the electric might go in the coming years. maybe just touch on why is that a limit for electric, and in terms of overall life cycle. Yeah. Mm-hmm.
Yeah. So the interesting thing if you look at the graphs around battery electric vehicles is that the price of batteries are dropping. Okay, but the technology isn't. And there's theoretical reasons and there's chemical reasons why it's not improving, but the technology isn't improving enough that it's halving in size. We don't have the Intel chip parity here with the battery. It's not halving in size or weight as we increase production, and that's a limitation, because that means that the generation car that I bought 2 years ago is a 28 kilowatt battery, I think it is. The new version has a 50 odd kilowatt hour battery in it. It's twice as much power, twice as much range, or almost twice, because the weight is extra, there's a loss there. So it's got twice as much range, right? This is the sell price, almost the same price, a little bit more expensive. So, but then if you go any bigger, you're into an SUV. And if you want to get 600 kilometers, you're technically driving a truck to bring your kids to school. So there's a limit there of the price will only go down so far for battery, and it'll stay at that point for pretty much ever, for most reasonable cases. Whereas what you can do, and again, our society needs to get the mindset of SUVs are not a good thing. We need to kind of go back to the family car, please. And again, having family cars or even an SUV, they are more energy intensive and carbon emitting in its life cycle than the small family car. So what I would see is that EVs having an average range of around 400 kilometers, unless you're completely crazy and you go into some massive thing, and that price then will be fitting with something like what we're used to today as a family car price, 20,000 euro or something like that. I think that's kind of where it'll sit, and that everyone will be happy with that. And if you don't like that, you have a fuel cell car to buy if you want, but it'll be more expensive, and you'll have to stop at a fueling station. So I think there's a huge behavioral, societal, social thing that really OEMs and governments need to kind of recognize on why people buy cars, and how what it means decarbonize. Decarbonize means we have to use less, or what sustainability mean in relation to decarbonization? We have to use less with more. And when it comes to transport, battery brings you so far, which is great. It's very efficient, brings you so far, but then we need to do other things to bring us the rest of the way.
And as you said earlier, James, also the majority of the CO2 emissions are coming from the heavier goods vehicles. So if they can be transitioned into hydrogen and electric, that's a very good place to be in the short term.
Yeah, not the for the scale. So 100,000 vehicles, 24% of emissions versus the 2 million vehicles causing the other percent. So it's a small number of vehicles with a big emissions reduction potential. That's maybe and then you move on to or you further push for cars as well at the same time. All these problems have to be solved parallel, most likely.
Yeah. Just looking at the time here, James, there's a much longer discussion here, but we'll wrap it up there. And I'll say thank you very much, James, for the presentation, and excellent presentation and answers to questions. Very thought-provoking and interesting. Thank you, James. Yeah.